Okay, so in behavior of polynomial is really important for graphing polynomials, of course, especially if you don't have a calculator, but it's really important in calculus. And what's scary about it in calculus is that you have notation to use, and a lot of people are already nervous about the concepts, that whenever you get thrown all these new notations, you just get kind of overwhelmed. So I mainly want to focus on the notation and what it means when it comes to in behavior of a polynomial. So basic, f of x equals y. You know that, right? F of x is function notation, and it's used instead of saying just y because it has a lot more information to it, right? You actually name your function, and instead of naming him Steve, you name him usually just a letter, whether it be F, G, H, alpha, gamma, beta, whatever. So anyways, usually it's just F and G for our college algebra stuff. But our goal when determining in behavior is determine what the function is doing at the end of the x-axis. So we're basically asking, if we're talking about our function, and our function is y, our function, what is our function doing? Well, all we're doing is asking, what is y doing? And we're literally only asking, is it going up? Is it going down? Right? We're not asking if it's going left or right, because left is in the x direction, right is in the x direction. We're only asking, is it going up or is it going down? Okay, now I have a whole little color coordinated system, so I'm going to change colors in just a little bit to all sorts of markers. But to properly state this in behavior, we fill in the blanks. As x approaches something, f of x approaches something, and those somethings are either positive infinity or negative infinity. The little arrow, I didn't leave a space for this, but that little arrow says approaches. So in math, all of our little notations usually have something that it says. So whenever you're reading this, you read as x approaches, and then you fill that in with either positive or negative infinity. Now, what do you fill it in with? Is it positive infinity, negative infinity? Is this positive or negative? That's what we're going to do right here. Talk about what do we fill this in with. So let's think about this statement, and let's think about writing it in proper notation. On the right, the function goes down. On the right, the function goes down. What does that mean? Okay, that means we're on the right-hand side and our function's going down. So how would we write that? We would write as x approaches what? F of x approaches what? On the right. So is right. So the right and the left, those are in your x direction. So would x be positive or negative infinity? Well, on this side, x is positive infinity. Think about that. You go up to positive infinity. Over here is negative infinity. So as x approaches positive infinity, what's your function doing? Well, if your function's going down, then what's your y value doing? Your y value going down is going down to negative infinity, right? Up here is y is positive infinity. So your f of x is going down to negative infinity. And that's how you would write the translation of that statement. On the right, the function goes down. It's properly written as x approaches positive infinity, f of x approaches negative infinity. Okay, next, let's look at this. So what we just did was we just said our entire graph, okay, our entire plane, not graph, but our entire plane. Hold on a second, let me stop this dog. Brownie, stop it. Shh. Hush. He loves rolling around growling. He's gonna do it again. Brownie. And Brownie's a girl, but everything else is a boy around here, so I keep calling her a boy. He's just so cute, though. It's hard to stop him. Okay, so here, consider the plane. Our plane has 4 coordinates, right? It has an up direction, it has a down direction, right? So your y value is going up to positive infinity, or it's going down to negative infinity. It has a left and a right. The left is when your x is going to negative infinity, and the right is when your x is going to positive infinity. So you can state what your function is doing in each quadrant just by saying on the right it's going up, on the right it's going down, on the left it's going up, on the left it's going down. You could say it like that. That's the basic college algebra way of saying it, okay? If you want to get into any higher math, you say it a little more properly, as instead of on the right you're going down, you say as x approaches infinity, your y value goes down to negative infinity. As x approaches infinity, f of x, or whatever you're calling y, right? F of x, g of x, whatever its name is going down to negative infinity, approaches negative infinity, okay? So instead of using right, left, up and down, you want to use as x approaches, comma, f of x approaches. So let's write that statement for each of these quadrants. So what I'm going to do is I'm going to use different colors. For my first quadrant, I'm going to use pink. How would we state this? Well, in our first quadrant, quadrant 1, we would say we always start with x. As x approaches positive infinity, y, or f of x, approaches, where's he going? He's going up to positive infinity. That's it. That's our statement. So now let's go to quadrant 2. Quadrant 2, well, now, as x approaches, this is quadrant 2, as x approaches, where's x going? Over to negative infinity to the left. What's your function doing? Going up to positive infinity. Then we go down to quadrant 3. Quadrant 3, I don't like using Roman numerals. Roman numerals, late at night, the 2 starts to look like 3 and 1 starts to look like 2, and it's really easy to get confused, so I like the 1, 2, 3. Anyway, so in the third quadrant, as x approaches negative infinity, as x approaches negative infinity, what's your function doing? Also going down to negative infinity. Lastly, in quadrant 4, we have as x approaches, it's going to the right, right? As x approaches positive infinity. What's your function doing? He's going down to negative infinity, okay? Now, your if you did not notice that, your quadrants are labeled 1 and they go counterclockwise, 1, 2, 3, 4. Okay, that's how you count. So you have your plane separated into up, down, left, and right. Basically, right? Like you know that. And then all you have to do is translate. Instead of saying right, instead of saying on the right, you say as x approaches positive infinity. Instead of saying on the left, you say x approaches negative infinity. And you always talk about your x's first and then the y's, right? Maybe you could say, think about it like you're talking to a friend and they say, oh, what happened to so-and-so? And you say, oh, yeah, they're an X now. Usually that's followed up by a, oh, why? What happened? Right? So the X's and then the Y's. It's also just like a coordinate, right? X, comma, Y. Whenever you're trying to plot a point, it's X, comma, Y. That's how you plot a point. So in the next 10 minutes, we're going to look at examples. So this is what, that's what you want to focus on if you're trying to learn the notation. It's really not that difficult. Now, specifically for polynomials. Oh my goodness. specifically for polynomials, we want to focus on the leading term of our polynomial. And in the leading term, you'll find your leading coefficient and you'll find your degree. So your leading term is really important because it tells you that leading coefficient and it tells you your degree. The leading coefficient tells you, whenever you look at your leading coefficient, it tells you positive or negative, right? It tells you if your leading coefficient is positive versus negative, it tells you the right in behavior. So your leading coefficient determines the right end behavior. Okay? It tells you if your leading coefficient is positive, it tells you that your function is going to go up on the right-hand side. Okay? It tells you that your function is going to go up on the right-hand side. So how do we, what do I want to say? I want to say it goes up, and then here, what that would say is, as x approaches positive infinity, your y value also approaches positive infinity. Now, what about if your leading coefficient was negative? You know, I should have color coordinated this with the other page. Hey, I grabbed the right marker. Okay, so now if it's negative, all that's saying, your leading coefficient being negative, says that your graph, your y value is going to go down. So that says as x approaches positive infinity, so that's on the right-hand side, your graph is going down. F of x is going to negative infinity. It's going down. So it tells you your right end behavior. It tells you whether it's going up or it's going down. Maybe I should write the words up and down. Up and down. Okay. Now the degree. What about the degree? So that was the leading coefficient. The degree tells you your left in behavior. So it determines the left in behavior. Now, we cannot write whether it's going up or down because the left in behavior is going to be dependent on the right in behavior in this case. Why? Because if we have an even degree, that means that the left end behavior is the same as the right end behavior. So an even degree says the left end behavior is the same as the right end behavior. So it's the same. What does that mean? So that means if the left is going up, if the right is going up, then the left is also going up. It says that if the right is going down, that means the left is also going down. It's the same. They go in the same direction, up or down, okay? So now what if it's odd? If it's odd, that means that the left in behavior is opposite of the right. Okay, I'm going to abbreviate that because I'm running out of room. But the left in behavior is opposite of the right in behavior. So what does that mean? That means if the right side is going, whoops, wrong marker. If the right side is going up, the left side is going down. That means that if the right side is going down, then the the left side is going opposite. It's going up. Okay, so if it's an odd degree, one side goes up, one side goes down. Every single time. An odd function, one side goes up, one side goes down. Every single time. Okay, so we're going to do a few examples. In example A, we have positive 5. Do you hear the coyotes? And maybe my baby crying in the back room. She's playing with her bubbas and she cries whenever they take a toy away from her, or if she wants a toy and she can't get to it. Ooh, you could probably really hear the coyotes now. Okay, so what we're going to do is we're going to sketch the end behavior for these 4 leading terms. So for just any polynomial, any general polynomial, I picked out these 4 leading terms, okay? So this isn't just y equals 5x to the 4th, it's y equals 5x to the 4th minus 2x squared plus 3x minus 7. I don't know, but this is the leading term. All that other stuff does not matter. All that other stuff is what determines these dots, okay? So what we're wanting to know right now is what's happening to the ends. What arrows do we draw? So we have positive 5x to the 4th. Does this 5 matter? Not really. That 5 does not matter. The 5, he is just a number, okay? The 1/2, just a number. The 2/3, just a number. 4, just a number. What does matter? What does matter is that positive sign. Positive 5, right? Positive 1/2. What does the positive tell us? The positive tells us that it's going to go up on the right. Positive says it goes up on the right. Now, where do you go from there? Where do you go from there to determine the other side? Well, there we go. The other side is determined, I'm going to go ahead and grab a different color. The other side is determined by this degree. The degree is even, so an even degree says that the end behavior is the same. Same end behavior. Now, what goes on in here? I don't know what goes on in there, okay? But if one side goes up, the other side's also going up because it's an even degree. Now here, part B, we have a positive leading coefficient, so that means the right side goes up. But what about the other side? Well, this degree is odd. And odd means opposite, okay? Odd means you have opposite end behavior. So instead of going up, it's going to go one side up, one side down. Now, I don't know what happens in between here, okay? I don't know what happens. It could look like that. It could go whoosh, 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 right? It could be a whole bunch of bumpies. I don't know. Now, let's look at part C and D. C is negative. D is negative. What does negative tell us? Negative tells us that the right end behavior goes down. Negative leading coefficient, right end behavior goes down, right? Negative, frowny face, goes down. Anyways, that's what I tend to think of. So now what does that mean about the other side? It means nothing about the other side of your function, okay? How do you determine the what the other side looks like? Well, you have to go to the degree. The degree here is even. So that means that it has the same end behavior. So if this side goes down, this side goes down. Here, our degree is odd. Odd says you have opposite end behavior. So if this side goes down, then this side goes up. We don't know what happens in between here. We don't know what happens in between here. We really don't care. That's not anything to do with end behavior, okay? To determine all of that, you need to find out x-intercept, zeros, etc. If you want to do even more, you could use calculus. But when you're talking about end behavior, you're talking about whether it's going up on the left. If it goes up on the left, up on the right. Up on the right is a positive leading coefficient. Down on the right is a negative leading coefficient. If they both go up or both go down, then you have an even degree. If one goes up, one goes down, one goes up, one goes down, you have an odd degree. Lastly, I want to pose a question, true or false, why or why not? A polynomial with an even degree will always have at least one x-intercept. Is that true or false? Think about it, and think about these two graphs right here. Then a polynomial with an odd degree will always have at least one x-intercept. Again, this is a true or false. I'm not saying these are true, okay? I'm not saying these are false. I'm asking you, are these true or false? So a polynomial with an odd degree will always have at least one x-intercept. True or false? One side goes up, one side goes down. One side goes up, one side goes down. One of them is true, one of them is false. You figure out which one's which.